Asyle, the engineer, and the island. Week 38, Day 1. It's a new week, but the weather hasn't let up yet. If anything, the storms are getting worse, which worries me a bit for my structures, but may also explain why the smugglers haven't come back, and may not be back for a while, which takes a load off my chest. In the meantime, I did my morning chores as best I could in the rain, before spending some time taking down the lamps in the courtyard so they wouldn't get damaged by the wind, as well as otherwise battening down the hatches. When that was done, I still had a laundry list of things to do this month, and not too much I could do while it was raining outside. More than anything, I need a stronger, more consistent source of electrical energy, particularly to power lights for the dome and tunnels, but mostly to power hot plates for the various cooking installations around the base. For that, I need more metal, and fortunately, mining is something I can do indoors, as it were. The only downside, however, is that I kind of have to run the explosives machine indoors, which I don't like at all. So I compromised and spent some time making a quick and dirty awning to protect it from the rain just outside the lab. I then got it started making more explosives, having accidentally left the nitric acid bubbler running again for the past week or so. I have a surplus of nitric acid to use up now. While the machine ran, I headed down into the tunnels. Part of the problem I expected I was going to have was that the lava tubes were disconnected from each other, and I didn't want to have to walk between them and the base in the rain. So, since I wasn't really going to have anything better to do during the rainy season anyway, and explosives are more or less a renewable resource at this point, I figured I might as well blast some tunnels between them, effectively giving me a network of secret passages all across the island. This will make it easier to defend in some ways, or escape when I need to, but at the same time, it's also that many more places I could be attacked from. Again, the rotating passage should help with that. I used my map to find a good spot where the tunnels should connect, and started drilling some holes for the explosives, placed in a vertical line along the stone wall, where they would hopefully blast out a tunnel about my height. I then returned to base to get the anfo rods I made last week and forgot about, set them, and lit them. The resulting debris from the blasts didn't contain any visible ores, so I simply raked the rubble aside to make way for the next blast. I measured how deeply into the rock I'd excavated, and it wasn't very deep, maybe a foot or so. However, I think that if I take the time to make the holes deeper, I might be able to blast out maybe up to 1 meter of rock at a time, which is still slow going, but much faster and less effort than I could do by hand with a pickaxe. I stopped to cook lunch at that point and considered my options. It may not have been worth the time and effort to blast that far into the hillside just to get to the lava tubes on the other side of the island without walking. At the same time, however, I knew that the supply of lava tubes on the island, and by extension metal ores, was so limited that I could probably count them on my fingers, so I would have to start mining that way eventually if I wanted to keep making metal. Might as well start now. Again, it's not like I'm going to have much better to do during the rainy season. So, after lunch, I got back to the same previous routine, preparing explosives, drilling deeper holes, and blasting my way deeper into the mountain. As I went, I made sure that my tunnel was in a direction and elevation that would intercept the other tunnels as well as remain deep enough that it was unlikely to poke a hole in the acid pond in the caldera of the island. At the end of the day, I had a pretty fine tunnel if I do say so myself. Starting to get good at this. I spent the last hour of the day repairing my drill and replacing my drill bits. Week 38, Day 2. It was still raining pretty hard today, so there wasn't a lot I could do outside. In fact, besides collecting latex and sap from the trees, I decided to cut my morning forage short because it was getting just a bit too stormy. So instead, I just got started on my explosives a bit early. I figured I could use all the time I could get. At the same time, though, I realized I was going to come up against another bottleneck soon, since I was running out of creosote for the ANFO. This means I'll have to cook and distill some of my precious firewood each day to keep up with demand, but at least I'll get some coal out of the reaction to cook the next batch with. Anyway, I spent the morning blasting away, stopped for lunch, and got back to it, clearing debris and smoothing the walls of the tunnel as I went. I was pleased that I'd gotten good enough at it that the explosives weren't misfiring anymore, and I've started getting used to the loud bang they produce. At the end of the day, however, something sounded different. A little deeper and more hollow than usual. When I went to inspect the hole, I was a bit perplexed and annoyed at first to see that the explosion somehow didn't do anything to the wall. This was only until I realized that the bulk of the explosion must have blown out the back of the wall, and not the front. It couldn't have been the tunnel I was aiming for, which was still a long way off. I used my pickaxe to hack away at the wall a bit, revealing a cave behind it, which I figured could save me a lot of time. In hindsight, I suppose this shouldn't have been too surprising, but you just assume that a solid rock wall is a solid rock wall that goes on forever into the earth. Once I had a hole big enough for me to get in and out of easily, I took some time to explore this new tunnel, and my surprise turned to awe as it led to a massive open cavern that my light couldn't see the end of. I wanted to explore more, but I knew it was getting late, so I hastily finished clearing the debris and returned to base. Before I could sleep, though, I gathered up my survey equipment, climbing equipment, and set my extra batteries charging, so I can see inside the cave better tomorrow. Week 38, Day 3. The storm cleared this morning, so before setting out to explore the cave, I performed my morning chores as usual, while giving the base a once-over to assess for damage. The chicken houses, at least, had been spared the worst of the storm, since they were situated in the understory. I can only imagine that the birds were grateful for the shelter. To my chagrin, though, some of the solar tower's panels cracked from impacts in the wind. I'll have to fix those later, so I prepared some replacement panels after foraging. With my maintenance concerns out of the way, I headed back down into the caves. With a fresh battery in my headlamp, the area was bathed in light, and I could get a clearer idea of what I was looking at. Though the far walls were still only dimly illuminated, I could see enough to tell me that I was looking at a nearly cylindrical shaft 100 to 150 feet in diameter, leading almost straight down into the earth, with a vaulted ceiling overhead studded with black stalactites. The awe of the discovery made me feel giddy and excited, though at the same time, trying to look down the shaft and being unable to see the bottom made me feel dizzy and nauseous. The whole thing almost looked unnatural, reminding me of the Great Shaft in Matanui Online Game 1, or Myst 5. But upon closer examination, as I carefully tried to survey the area, far from the edge of the hole, I got a clearer picture of how the place formed, and by extension, the geological history of the whole island. The island appears to be a shield volcano, as most volcanic islands in the Pacific are. These volcanoes are characterized as having very runny lava compared to other types, which is why they spread out so much. This is also why they form lava tubes, because the lava is so runny that it may continue to run through, under, and over areas that are already solidified, after which the lava levels drop, leaving a hollow vein behind in the earth. Looking at the edges of the shaft, I found that it was ringed with natural stone terraces, which sometimes led up and down between levels. This led me to believe that the lava levels of the volcano temporarily settled at different levels, allowing it to cool around the edges before dropping, collapsing the volcanic scab in the center, leaving the firmer edges behind. This painted a picture of the island having an overall stunted geological history. What I imagined was that a hot spot formed in the crust under the ocean and allowed magma through, like all volcanoes of this type. But for some reason, the pressure of the lava in this area of the crust wasn't very great and prone to fluctuations, causing the hole to overflow just a little bit each time until it was just poking out of the surface of the ocean. At some point after that, pressure started falling overall, while still fluctuating, taking the lava with it, forming this shaft, the terraces, and the roof overhead as the lava cooled. This may also help explain why I've found as many sulfide minerals as I have, as they were lighter than the equivalent oxide minerals and floated to the surface of the lava, getting left behind like sea foam on the beach as the lava retreated. I took my headlamp and carefully picked my way down the terraces, many providing ramps downwards, as I said, but others forcing me to rappel gingerly. I did my best to map everything out as I went, finding more lava tubes off the main shaft that may lead back to the ones I've already explored. I suppose that gives me the way to connect them all that I asked for, even if it doesn't exactly fix the travel distance or security problems. Eventually, I made it to the very bottom of the shaft, which sloped gently down from the edge with a spiky bulge in the center, where I imagined lava and hot gases tried to get out from time to time. I estimated the shaft floor to be about 50 to 60 feet below sea level, which also told me I need to be careful about where and how I mine from now on, if I don't want to accidentally flood the shaft. The centerpiece was coated with sulfide minerals that squirted out of this last hole in the volcano. Almost feels like a trap. However, I know that if the lava was still anywhere near the surface, I would feel the heat through the rock. Still, this is also probably the closest spot on the entire island to a source of significant geothermal heat, and therefore probably the only large and reliable source of energy. The hard part will be getting at it, since I have no idea how deep that heat might be. I know that in most places on Earth, the crust doesn't reach the critical point of water until a depth of about 12 to 15 kilometers, though because the island is over a volcanic hotspot, this may be significantly less. I thought about these things a little more when I headed back for lunch. At least I had solar energy to cook it with this time, as I've otherwise just been snacking on the stuff I've already dried. I considered the possibility that it may be time to try out one of my more speculative invention ideas. This isn't the first time I've thought about geothermal energy collection, since it's abundant and more or less evenly distributed across the Earth's surface, just hard to get to, usually involving massive and expensive drilling rigs that hardly get close. I had an idea for a way to vastly simplify the drilling process by using jets of water to cut into the rock using cavitation, created by differences in the water's flow rate as it rubs up against the sides and bottom of the hole. I was inspired by a documentary about a massive flood caused by the collapse of glacial Lake Missoula at the end of the Ice Age, which carved out the channeled scablands in Washington state and created huge potholes in the bedrock by cavitation. I figured that if cavitation could cut through stone there, it could cut through stone for me here. It's just going to be tricky because, 1, I don't know if this is actually going to work, and 2, it's going to require a nozzle of a very specific shape. Still, I don't see what I have to lose beyond my time. I doubt poking a long, thin hole in what's left of the island's magma dome would set off an eruption, any more than a mosquito could pop a water balloon. Besides, I don't have much better to do with my time, and, by hook or by crook, I need a better source of electrical energy. So, after lunch, I spent some time properly designing the drill head and carving a jig to help me make many of them fairly quickly and consistently, as I didn't expect them to be completely immune to cavitation. I decided that I might as well make them out of ceramic instead of much softer metal, so I molded them out of clay and left them out to dry with my spare reflector panels. Next, I knew I would need pipes, but I figured I could make them out of bamboo later. More importantly, I needed a pump, and I remembered calculating that the requisite pressures and flow rates for my original Cavitation Vortex Drill could be achieved with a normal pressure washer, about 2 ksi. However, I highly doubted my rubber diaphragm pumps would be up to the task. I needed something more powerful, and the best thing I believed I could make under these conditions was a Tesla turbine. It consists of several flat discs stacked on top of each other with a gap in between them and rotated about a common axis. The discs drag on the water near the axle, and centrifugal force flings it out to their circumference at great speeds. It could even be run in reverse to turn fluid flow into mechanical energy. It was never used to its full potential, however, because no material for the discs existed at the time that could handle the centrifugal force without being torn apart. I thought, however, that I might be able to compensate for this the same way I did with the air bladders of my diving suit, using high tensile strength materials, in this case bamboo cord, for the conditions where they were strongest. I gave it a try, making a couple of small spoked wheels and wrapping cord around them from the inside to the outside and back again. Kind of reminded me of the old wicker pot rests we used to have back home. This will at least ensure that the cords will take the brunt of the tensile forces. Then, to make them smooth, I coated them in hot resin, effectively making a sort of all-natural fiberglass. I spent a couple of hours building these, and then built an axle to hold them together, having the clever idea to use the axle as the delivery pipe for the fluids, drilling holes in it between the discs where the water could flow out. I had to drill holes in it anyway for the disc spokes to fit into. The seal between the axle and the bearing, of course, wasn't going to be watertight, but I was counting on the water actually helping to lubricate the interface between them. That was about all I had time to do before the end of the day, but I have the rudiments of a Tesla turbine now. One issue with using a Tesla turbine for this application, though, is that it's really designed for high flow rate applications, as opposed to high pressure applications. But I should be able to control this by changing the diameter of the pipes, as per the Bernoulli equation. The only remaining problem will be powering this pump, and it's kind of a chicken and the egg problem. Because I want to bore a hole so I can get mechanical energy, but I need mechanical energy to drive the pump to make the borehole in the first place. And unfortunately, there's no wind, water, or solar energy down in the cave for me to run it with, and I'm certainly not going to be able to run it by hand, nor do I have the fuel to power it with fire. This means the only thing I can reasonably do is build a motor and run it with electricity, running lots of copper wire through the cave system, or run it on a battery. At least I can recycle the motor into a generator when it's done. Whatever the case, I need to get to work mining ore again as soon as possible. Week 38, Day 4. It was another clear day today, which was a relief, and when I got up in the morning, I set the replacement solar panels and drill heads in the kiln to fire for the day, before doing my morning chores. I wanted to get back to work on mining, but I was still concerned about my fuel situation, especially if I would be needing anfo to keep blasting. Furthermore, I needed to take advantage of the dry days when I could, so I decided that, unfortunately, I really need to cut down another tree. I found a good candidate, not another coconut palm, which appeared to be on its way out anyway, strangled to death by a ficus, which was going to go down with it. I then proceeded to chop it down with my axe and transport the logs back to base. I took an early lunch before chopping the logs into rounds and feeding the rounds into the chopping machine for the rest of the day. I was running out of room to store firewood in the workshop, so I stored most of it in the lower level of the solar tower or in the beach hut. I checked the barometer before I went to bed, and the pressure had dropped a bit, so I'm expecting the weather to start deteriorating again tomorrow. Week 38, Day 5. It's raining today, but not nearly as hard as before, so I was able to get a little foraging done before buckling down for some mining. I started the explosives machine, placed my charges, and lit them throughout the day, though not in the shaft because I couldn't get my bomb suit down there safely. I'm going to have to build another elevator at some point. Instead, I started mining out the tunnels on the far side of the island, so there was a bit more legwork than I would have liked, and in the rain to boot. Still, I got several good loads of ore, mostly copper and lead today, and I loaded them into the grinder to separate overnight. I checked the pressure before going to bed, and it was still dropping, so I made sure to batten down all the hatches again. Week 38, Day 6. It was a bit of a squall this morning, so I wasn't going to get out much. I could barely get to and from the lab to start working on another round of explosives. I blasted a couple of the ore sites that I could safely reach with my bomb suit in the shaft, though a lot of the ore got scattered over the edge of the walkways and down to the bottom. I figured my time would probably be better spent blasting to the next lava tube network, so I worked on that for the day instead. It was a kind of disappointing end to the week, but the storms made it kind of unsafe to leave the house. So much so that I'd actually taken to going to and from the different buildings in my bomb suit, because it weighs me down in the high winds, in addition to keeping the rain off. At the end of the day, I made one more round outside of tying things down, and making sure anything that could be destroyed by the storm wouldn't be. Week 38, Day 7. It's Sabbath, and to my surprise, the storm hadn't stopped this morning. If anything, it had gotten worse. I was getting really worried that something big was going to be destroyed this time, but there wasn't a lot I could do. I tried to take my mind off it by writing, drawing, listening to the sermon on the radio, and transcribing my Bible passages, but it was hard to hear over the howling wind outside. When I was done, I felt like I couldn't take the chaos outside anymore. I needed a retreat, so I figured the underwater dome was probably the best place to hide, from storms and smugglers. I climbed down into the caves where the sound of the storm was muffled, put on my diving suit, and descended into the pool. The force of the storm could still be felt even in the tunnel, as the wind and waves outside caused the water in the lava tube to pulse up and down, pushing me back, pulling me forward, and sometimes knocking me off my feet. When I made it to the dome, however, all that chaos seemed to melt away. I looked up and saw the surface heaving up and down. From down there, it almost looked like great claws reaching down into the water, trying in vain to grab me. Between the waves, I could hear the rain pelting the surface like hail on a tent roof, but muffled. Here, I was insulated, and I breathed a big, heavy sigh of relief. as I could finally start to relax and let my anxiety slowly drip away from me like the seawater off my suit. I sat in the upper level for a little while thinking, listening to and enjoying the storm sounds outside. This whole structure kind of feels like a lavish gift to myself, and perhaps more essential than I initially thought, so I also figured I needed to take good care of it. I made the rounds thickening the seams again, though fortunately at that point, any leaks appear to have been permanently sealed, but you can't be too careful with something like this, I suppose. Then I spent some time tending to the garden. Fortunately for me, many of the plants have taken root, and of course, it's the bamboo that started to grow first and fastest, though not nearly at the same rate as the ones on the island, probably because the light was dimmer down there. I then stopped for lunch. Fortunately, I'd already stocked the dome with some dried foods, since the cooker wasn't working yet. I didn't go down there to just sit around all day, though, so after lunch, I installed my shark collar and chum bubbler apparatus, though at the time, I had no chum to feed the sharks with, and there weren't any sharks near the dome anyway because of the storm. Instead, I decided to use up some of my super oxide on a dive. The water was much calmer further down the reef, and as I went along, it occurred to me that the elevated pressure and oxygen levels in my suit may replicate the effects of certain medical research I've heard about. Normally, an excess of oxygen will cause oxidative stress to cells if exposed to it for too long. But if a person is exposed to high oxygen concentrations and pressures for a short period of time, when it's taken away, it creates another kind of stress on the cells that causes them to think they're running out of oxygen. This causes them to reset their epigenomes, reducing or even reversing cellular aging. So, taking these periodic dives once a week may in fact help extend my life and youth. Thinking about medical projects and experiments gave me another idea for something I could do when the storms rage and there's nothing I can do outside, namely microbiological experiments. My knowledge on the subject is relatively basic, but I've had ideas for genetically engineering microbes for food production and medical functions in the past. I wouldn't even know where to begin figuring out how to splice DNA under these conditions, or how to create, isolate, or use CRISPRs, but I might be able to do a few interesting things with selective breeding. It's worth trying, if only to see what'll happen. So before I was done with my dive, I collected as much seaweed and algae as I could so I could create agar-coated petri dishes later for growing microbes on. As I did, I thought about how I was kind of helping the reef by removing plants that would compete with the coral for sunlight. I also thought about how the algae would have ended up growing much more intensely if I'd been dumping my excess ammonia and nitrogen-rich compost into the ocean, so I'm glad that I've done my best to keep my business contained, both on the island and in the dome, though I'll have to find a way to safely empty the toilet there eventually. I returned to base because there was really nothing I could do with the algae without cooking it first. The storm was pretty bad, though not as windy as before. I kept my diving suit on, however, because of the rain. Besides, it would wash away the corrosive salt water. While I was in the kitchen, I figured I might as well get a head start on cooking dinner, too. Otherwise, I boiled the alginate out of the seaweed and slowly reduced it down to a hard jelly that I could coat onto some petri dishes. In the meantime, however, I needed some petri dishes to coat in the first place, so I ground out some flat lenses in the workshop to function simultaneously as petri dishes and microbe slides. When the time comes to use them, I can sterilize them with my pressure cooker before inoculating them. In the meantime, I would need some kind of incubator to keep them at an optimal temperature for microbial growth, but this could pretty much be any old pot, as it would be pretty thermally insulated. And it's always so warm here anyway that microbes will probably grow like crazy as long as I keep them out of direct sunlight. Still, I kind of wanted to do my due diligence, and I figured that if I put something in or around the incubator that was already in the process of being decomposed by microbes, any additional heat they generated would make them start to kill themselves, slowing down their growth that much more, automatically balancing the system for maximum growth rates. I figured the ethanol brewing pod in the lab would be perfect for that when the time came. With a little time left at the end of the day, I spent the last hour of the evening writing before getting ready for bed, though I slept downstairs again so the storm sounds weren't as bad. Got bloopers in the rain, just bloopers in the rain. That would intercept the other tunnels, but you just assume that a solid rock wall is a solid rock wall is a solid rock wall that is a solid rock wall is a solid rock wall is a solid rock wall. Blah. To my chagrin, though, some of the taller what am I saying? Looking at the edges of the shaft and carving a jig to read the words, running lots of copper wire through the cave system. And when I got up in the morning, I set the replacement solar panels and drill heads in the kiln. Are you done? Which appeared to be on its way out anyway. I didn't go down there just to sit around all day though. I installed my shark collar and chum bubbler apparatus. Built a little gravelly today, aren't we? I had no chum to feed the sharks with, and there weren't any sharks near the dome. And there weren't any sharks near the dome anyway. It's a shame, because this is a good shark right here, Merle. He takes a pet, no problem. Ow! Is relatively basic, but I've had it. So while I was done with my dive, preposition troubles. Pause for edits. Where was I? Hey there, thanks for listening all the way to the end. I'm really jazzed about this new Cavitation Vortex Drill project, as it's one of my actually original inventions in real life, and it makes me happy that I've gotten to share it with you. Whether or not it's a good invention, however, is in the testing. So, if you want to see if I manage to successfully drill a hole to the center of the Earth with it, you can press the subscribe and bell buttons to get notified as soon as the next episode is ready. If I find any dinosaurs down there, that's how you'll know I've officially jumped the shark. Now, I'm not trying to make money with these videos, but it would help me out more than anything else if you could share these videos with someone who you think would enjoy them. And since you apparently enjoyed it enough to watch it this long, you can press the like button to say so, and to tell the algorithm to do a bit of that sharing for you. Also, if you'd like to chat about some of your own stories and perspectives on the episode, maybe about something cool you found while spelunking, or about your favorite place to go and hide from the world when it starts becoming too much to process, feel free to share them in the comments section below. I genuinely love to hear them, and I'm always open to suggestions and corrections. That said, thanks again for listening, and hope to see you here again next week.